Hello and welcome back to Class Time, your daily classroom for CSEC students.
Today's mathematics lesson will be focusing on set theory. I am Tamika Lodge-Fenton.
And I am Camille Johnson Borrell. Let's go.
Let's begin. So today's objectives are to determine elements in intersections, unions, and complements of sets, as well as construct Venn diagrams to represent relationships among sets, and solve problems involving the use of Venn diagrams. So Camille, what is a set?
Some things are put together, you know. Maybe my suit is a set.
Well,
my blouse and my pants and my slipper, my watch, all this. I think this is a set.
it's a set because guess what happened? Everything that you just named, Camille is wearing. So a set has something to do with something common. They're all on you.
Yes,
So let
I'm the
us-
one in common right here with my
That's
clothes.
right.
All right.
Everything that you just listed. You hear the terms I'm using. You just listed some items, some elements, and they're all on Camille.
And they're all a part of my set.
Your outfit for the day.
All
So
right.
let's look at what is a set if we're talking about anything else out there. So sets in mathematics are an organized collection of objects that share a common property and can be represented in set builder form. Usually sets are represented in curly braces and with a capital letter. For example, set A, 1, 2, 3, 4 is a set. So all those, and let me just repeat that. So set A, you start it with your one curly brace, you put in your elements, 1, 2, 3, 4, you enclose that set with another brace. All right? So you agree with that?
Yeah, man, I agree. I think I agree with that. And guess what? We were talking about what I was wearing. So here we
Exactly.
have the items you wear: hat, shirt, jacket, so on, blouse,
be.
pants, whatever, can be a part of a set. And it's the same. We have
There you
them
go.
here in curly braces.
Excellent. So as you can see here, at times sets can be represented with pictures, with little illustrations. Most times though you'll see the items listed, but that's still a set there.
Still a set.
All right.
So let's take a look at this scenario. Nicola was in math class with her friend Romée. She whispered to Romée that she had just bought a set of summer clothes. The outwear collection includes a swimsuit, hat, a summer dress, scarf, and a pair of sandals. Their teacher, Mrs. Fenton, overheard the conversation and asked them, 1, how would you write this as a set? And 2, how many elements are in the set?
All right. So we just established that a set is a collection of organized things, and we did say that it must have something in common. They already spoke about the summer clothes, the set of summer clothes. So pretty much we want to look at all the things that they would have said. The swimsuit,
The outwear
hat,
collection,
summer
right?
dress, scarf, and sandals.
Yes.
Let's just put that in a set.
And we need to name our set too.
Exactly.
So the set of outwear for Nicola would be listed as follows, and we're going to name this set A. So A, which is the set, equals the set of swimsuit, hand, scarf, hat, scarf, summer dress, and sandals.
Exactly.
Where A is the name of the set, and the braces indicate that the objects written between them belong to the set.
So we now know that set A has all the items that Nicola would have in her outwear for the summer,
But
right?
we were asked another question.
Yes, we were.
How many elements were there in this set? So let's count. Swimsuit is 1,
1,
hat,
2,
scarf,
3,
summer dress,
4,
and sandals.
5.
So we have 5 elements in this particular set. So let us discuss here now. So we're going to let set P be the letters that are in the word mathematics. And we all know how to spell mathematics,
Of course we do.
right? All right. So let's list the members then.
Can
That
I
would be
try
the set.
before I even look at... So the
All right,
set...
so I'll write while you're trying.
Right, so we have set P.
Set
so we
P.
name the set.
Yes.
We use our curly braces. M,
M,
A.
A,
I because we can spell is T,
T,
H,
H,
E,
E,
M,
M,
A,
A,
T,
T,
I,
I,
C,
hold on, C,
S.
S.
So, am I right?
No, guess what? You're going to have two M's in the same set.
But you said the letters that make
Yes, but look at this. Don't you see M's are being repeated? You have A's being repeated, T being repeated.
So you just want the letters. You just want the letters. So once M is in there, I don't have to put the M in again.
Not at all. So as long as you have a letter there, you don't have to repeat this because it would have already been accounted for in this set. So go again now. I'm going to let you try again.
Let's do that again. So it's M,
M,
A,
T,
H,
H,
E.
E.
M is already accounted for, so I don't need to write that. A is already there.
Right.
T is already there, so it's I, C, S.
Good girl.
All right, so what you're saying, though we're talking about the letters that make up the word mathematics, I do not need to repeat the M's or the A's or the T's because it's already accounted for.
Right.
Okay, so when we look at the elements of P, we're just looking at the distinct elements, which are M, A, T, H, E, I, C, S.
Yes.
Let me describe that set though. It is the letters that are in the word. And these are the letters that are in the word. M, A, T, H, E, I, C, S. Although they're repeated within the word, it doesn't change that it's just M, A, T, H, E, I, C, S in mathematics.
Yes, that's correct.
All right.
And remember, we did say these are the distinct elements of the set or the distinct members. So we can interchange the term elements, members, elements, whichever one. So the elements that are written in the set can be in any order, but cannot be repeated. And we would have stated that earlier. But before you move on, can you tell me then how many elements here are in set P, just looking at it?
Okay, I can definitely count it. So it's 1, 2, 3, 4, 5, 6, 7, 8.
All right, so it's M, A, T, H, E, I, C, S, which gives you 8.
Right.
All right, that's good. So all the set elements are represented in small letter in case of alphabets, which we looked at earlier when we were listing the elements in set P. Also, we can write it as A is an element of set P, T is an element of set P, etc. We could say M as well is an element of set P.
And just to reinforce what you said up here, you said the elements are in lowercase. And that, if you realize, we name the set using a capital letter.
All right.
So distinguishing it when we're doing set builder notation, the members or the elements are always in lowercase, so you don't make a mix-up with the name of the set.
Yes.
So what were you saying now? A is an element of P. T is also an element of P, and we could definitely talk about all the elements in that set.
All right, and we did look at the cardinal number of the set P, which was 8.
So it has 8 elements or members.
Yes, and here we have brought it back up for those who are not sure how we arrived at the 8. So M1, A2, T3, H4, E5, I6, C7, and S would be 8. All right.
Awesome stuff. All right, so we're now looking at operations and sets.
Operation sounds fun.
In set theory, the operations of the sets are carried when 2 or more sets combine to form a single set under some or of the given conditions. Some of the basic operations on sets are union of sets, intersection of sets, and a complement of a set. So those are the things we're going to look at today in our lesson, right? Union, intersection, and
complement.
Okay.
All right, I think we seem to be getting there. So let's look at union of sets. Union.
What do you think that is, though? Union.
All right, so with union, 2 or more things then coming together.
Like a wedding,
yes,
right?
So you have
one family join with another family, and then you have this big family. It's like a wedding, man.
Same.
So let us look at the union of a set. If set A and set B are 2 sets, then A union B is a set that contains all the elements of set A and set B. It is denoted by or as
A union B. And this is our symbol for
right?
union.
Looks like a U. And you say A union B. All right. Let us look at an example. Go ahead, Camille.
So set A is the set of 1, 2, and 3, while set B, 4, 5, and 6. So now we're trying to figure out A union B.
Exactly.
What did we say union is again?
Just think about the wedding. One family come together with another. Everybody is now one big family. So if we're talking about A union B, we're talking about 1, 2, 3, 4, 5, 6.
All right, you get
That's
it.
simple.
You get it. You get it. See
There you go.
You're getting it.
So
let's look at another example now. So set A is the set of counting numbers less than 10.
So you do something different here, though, Camille. You didn't give me the members.
No,
you,
sir.
You
I want to
describe
see
it.
if you know what counting numbers are. Set B, even numbers less than 10. So see if you can tell me what are the counting numbers less than 10.
All right. So we know that since it's less than 10, 10 not in it. That's the first thing I know.
Great,
All
great.
right. Counting numbers start with 1. So you're talking about 1, 2, 3, 4, 5, 6, 7, 8, 9. Because you said less than 10. 10 is not in it.
All right. What about set B?
Even numbers less than 10. 10 still not in it. All right. So you start with even numbers. First even number is 2.
All right.
2, 4, 6, 8. I've got this.
All right. So let's see. Let's see. Good. Kudos.
So,
let's look at set
all
B
right.
now.
There
so
you
now
go.
you have to tell me A union B. Let's see what you're going to say now.
You can just write out everything in an A and then write out everything in a B, miss.
So watch this now. So I'm writing out everything as you would have said. So
Yes.
A union B. Remember, you said write out everything.
Is two
All
families coming
right.
together.
Watch this, I want you to ensure that you're looking carefully.
Well, oh, I just remember what you spoke about first. We said that you don't repeat the element. If it is already in the set, you don't have to represent it a second time.
Good.
So let's fix that then. So 2 is already in set A, so you don't have to put that in there. 2, 4, 6, 8. Oh,
So we
my.
don't need two twos.
We don't need 2 2s.
All
We
right.
don't need 2 4s. We don't need 2 6. And we definitely don't need 2 8s.
All right. So what are we left with now? Let's take a look.
So
what
look
we're
at
left
this.
with.
This is a unit case. So all of set A is really the union of the set.
Yes.
Okay. So I don't have to repeat it again. So it is 1, 2, 3, 4, 5, 6, 7, 8.
9.
9, 9, 9, 9,
Right.
9. Right, because that's the counting numbers less than 10.
All right.
All right. Great.
See, there goes.
All right. So although we talk about the union and the two sets come together, we have to pay attention if the elements are repeated, even in the second set, you don't repeat it in the union, in the elements found in the union.
Right, and it's the same as how we were talking about family.
Right.
So if one family comes together with a second family, so a husband and a wife, they have a child, it's one child. So we don't say, oh, daddy has a son while mommy has a son. It's the same son.
Right, because
So
you
we-
don't have to repeat it when
Good.
you're talking about it. Okay.
Yes.
Okay, fair enough.
So we're now going to take it a little notch further. Let's see what is up. We should be looking at intersection of sets.
All
Great.
right.
So if set A and set B are two sets, then A intersect B is the set that contains only the common elements between set A and set B. It is denoted as A, and we see the symbol here. Looks like a
upside down
river. Right. Intersect B. So let's see if we think we get what we just would have read.
All right.
So set A is 1, 2, 3. It's the set of 1, 2, 3, 4. And set B is a set of 4, 5, 6.
Or
What
before
would
you
you
ask me
say?
any question, let me just look at what you just told me. So you said an intersect. So if A intersect B, it is a set that contains only the common elements between set A and set B. When you say common, you mean it's in set A and it's also in set B.
Great.
All right, so let's look at that. Set A would have 1, 2, 3, and 4. Those are the elements.
Yes.
Set B has 4, 5, 6. The only thing that's in both of these sets is 4.
Great.
So A intersect B it has to be 4.
Good job.
There you
Good.
go.
Great job. But we're going to look. I need to check to ensure that you get it. So here's another one. So set A, still 1, 2, 3, and 4. But guess what? We're introducing set C to be 5, 6, 7. Now I want you to tell me what is set A or A intersect C.
All right, so this is easy.
I'll give you 5 seconds.
All right, you see 1, 2, 3, 4 up there, and then you see 4, 5, 6. They don't have anything in common.
Where are you see 4?
5, 6, 7.
Where are you see 4?
5, 6, 7.
All right.
There's nothing in common there.
So if there's nothing in common, what will be in those curly braces then?
It's an empty set, miss. It's a 0 set. Don't have anything in it.
Good. So since set
I could put 0 in it though?
No, it's an empty set.
Can't put 0 in there. Okay.
All right. So since A and set C.
A intersects C.
Yes, A intersects
There's nothing
C.
in common.
No, we call it an empty set.
Because there's really nothing in it.
No.
No element will appear in that set.
No
so it's
element.
an empty set.
No member.
Oh.
No members
I hear
of
this
family.
This term, null set. That's the same thing?
Same thing as empty set. Same thing. And here we have the symbols. This is how we would represent the empty set.
Okay.
So we represent the empty set with 2 curly braces, or some persons may say 2 curly brackets. Or we use this symbol here to represent null.
Which is a 0 and a slash through it.
Yes, something like looking like that.
All right then.
All right, so we would have already spoken, so they have nothing in common,
So it's
nothing whatsoever.
empty set.
Empty set or null set. So now we're taking it a little bit further to look at the complement of any set P is the set of all elements in the universal set that are not in set P. It is denoted by, and is a little P, is a
and a
P, the
superscript.
capital P, the superscript to the right.
Apostrophe?
We can say maybe an
Yes.
apostrophe, yes.
Right.
But this is basically how we represent complement.
Complement of a
So
set.
P complement, that is how it is
All
represented.
right. So just for those who are out there and listening, the complement is anything that is in the universal set that is not found within the set.
Right.
Okay.
So it's outside of that
the
set.
set.
Yes.
So, okay.
Outside. Remember now, outside.
All right.
So here we have A, set A is 1, 2, 3, 4.
Correct.
And we have our universal set here being 1, 2, 3, 4, 5, 6, 7, 8. What would be, come on, all right, so list the members of A complement. What would be
All right.
A
So first
complement?
I'll have to examine what is in A, and I realize it's 1, 2, 3, and 4. In the universal set, I would just look what is not in A but in the universal set. So that would be 5, 6, 7, and 8.
Great. All right. So the complement of set A contains the elements present in the universal set, but not in set A. The elements, as you would have listed earlier, are 5, 6, 8.
7.
7, 8. Right.
All right.
And here we have it. We would have
How do
written
we write
A
it?
complement, and we have placed the members of this set within the curly brackets.
Awesome stuff. So we're looking at A complement and okay. All right, cool.
Let's take a look at Venn diagrams. Venn diagrams represent a universal set. It is also a pictorial relationship between 2 or more sets. And the universal set is represented by a rectangular region and circles. So
All
let's
right.
see if we can just sketch something looking like a Venn diagram.
There you go.
So here we
So you
have,
said the rectangle represents
Yes, so
the
I'm just-
universal. So
right.
that big rectangle is universal there. And it can also be a circle.
right.
So we have set A inside. You want to label the rectangle as U?
Yes, so
All right.
this is my universal set.
So when
That's
we're
my
looking at Venn
universal
diagrams,
set.
it can be represented as a rectangle or a circle.
So
and
we
of
have
course
rectangle,
you'd have,
we have our circle. Right.
and of course you'd have a subset within the universal set. And in both sets, it's set A.
Yes, that's
All right.
correct.
Awesome. All right.
So we would have learnt about intersection.
Union
We learnt about union and complement.
Okay. What is intersection?
They have the child in common. So,
Right. So
yeah,
when you
the
have
family
sets,
comes to-
whatever
yes.
is common to both or
Yes.
all the sets.
Yes.
Okay. What about union?
Everybody come together, man. Everybody.
Okay. And remember, there's a key point to note. We don't
We don't repeat.
any
All
of the
right.
members. Once it's listed,
Yes, we
it's
don't
fine.
repeat it.
Okay.
Right.
And then what else is that? Complement.
Compliment everything outside of that
the
set.
Awesome. And it must be in the universal set.
In the universal
All
set,
right.
right.
We're looking good. We're looking good.
So
we're
let's
looking
see
good.
if we remember what we would have just said, Can you
Okay.
name the shaded regions for the Venn diagrams?
Of course, this. Right there should only be. That's easy.
All right, so you got that one. What about the second one? Tell me what you see happening with the second
It's
one.
A and B. But I
Good.
don't think it's anything about any and. It's A union B. It's everybody.
All right, good.
Everybody.
Good. Let's
Okay.
take it a little bit step further now. What about 3?
3 is set A.
Set A, all
A.
right, great. What about 4?
So why you leave out piece of set A? So it is only. Oh,
Set
there's
A,
no right. So it's set A only
all right.
because it don't go into B. So it's set A only.
Good.
Or B complement intersect A.
So guess what? We would have thought
B
about the
B
complement
complement would have been everything outside of, whoops. Let us look back at that. B complement would have been everything outside of B, right? But then it says intersect with A. So although this in the rectangle would be outside of B, because it's intersecting with A, it has to be something that is common. But only that little area is
Only
shaded.
set A is shaded.
Well, you can cut. No, set A is not shaded because see, piece of set A is not shaded.
So set A only is shaded.
Well, yes.
All
But
right.
then you used B complement intersect A to also represent that. Please explain that to me.
All right, so we're going to explain. It's not a problem. So here we have
The
a
Venn
little
diagram.
example of what is happening
Okay.
there where you have. So here we have this Venn diagram. We have set A, we have set B. So the first thing we're going to do is we're going to list the elements of the universal set. So let's
Okay.
see if you can tell me.
So that would be 1,
1,
2,
2,
3,
3.
and 4.
All right, great. Now I want you to look at this and I want you now to list the elements for me of set A.
Sure. That would be 2 and 3.
2, 3. All right. What about set B?
That's 3 and 4.
All right. But we want one more thing. I want you to tell me how you arrive at B complement. So what are the members of B complement?
Okay, so we had said that B complement is everything that's outside of
right. So here I'm covering B.
B. Right,
So let
so
me
that
cover
would
B.
be 1 and 2.
All right. Good.
But you didn't do, okay.
But look at this now. You have on your diagram that set A only is shaded. So we
But
need
you're
to-
calling it B complement intersect A.
All right, so we're now going to look at what is B complement intersect set A.
Okay.
So we're looking at set A. So I'm going to circle the two sets that we're looking at out of the universal set here. And we're looking at B complement.
So B complement is 1 and 2. But it looked like you don't want the 1 at all.
No.
You just want the 2.
Great.
So because you want the 2 only, you said B complement is 1 and 2. But if you intersect it with A,
Right.
you don't get the 1.
Not at
you
all.
You just get the 2.
All right.
All right. So B complement intersect A will give me 2.
But watch this
which
now.
is the same as A only.
Yes, that's what I was going to say, because if we take a look here, we will see that A only
It doesn't go over into
right
B,
here. So
no
it doesn't go into
intersection.
that intersection.
Right.
So into the overlapping of the two sets, it doesn't go anywhere
A
there. So
only.
it's A only, good.
Or-
and this A only is the same as B complement intersect A, which is also 2.
Awesome stuff.
So you think you get it now?
I think I get it. So what you're saying, although this is A only, I can also describe it a different way.
Yes.
Which is B complement,
Right.
it's outside of B. Although 1 and 2 is outside of B, I don't want the 1. I just want the 2. So if I look at B complement intersect with A,
Yes.
I will get only the 2.
Only the 2, which
All
is set A
Only.
only.
Got you.
All right.
So that's 2 ways in which we can describe this
This-
shaded region.
Right, on the Venn diagram.
This is some
Great.
good stuff.
Yes, so let's look more now to see if we get this. So here,
That's easy coming.
Of course.
That's A. That's set A.
set A, right.
You're trying to trick me now. All right. So let's look at that. We
right.
would have shaded everything outside of A,
Right.
right? Everything outside of A. So that's A complement.
Good girl.
Everything outside A.
Good girl.
Okay.
So let's take a look at 2 more before we talk about another one. This
All
one
right.
is pretty simple.
Yeah, that's an intersection. That's common to both set A and set B.
Great.
All right. So it's A intersect set B.
All right. And this
This
one?
this is easy. This looks like the wedding family. Set A, union, set B.
All right, that's good. But here what now? We're going to think about this one. You have a universal set to be 1, 2, 3, 4, 5, 6, 7. You have set A to be 1, 2, 3, 4, and set B to be 5, 6, 7. Now,
Yeah.
what I want 2 questions I have for you.
Okay.
How can we represent the sets in a Venn diagram? And guess what's the next question?
I don't know.
Describe this relationship between the 2 sets.
All right, make we put it in the Venn diagram. We can do this.
So you want me to try and help you out here?
Sure. I'll just tell you what to do, because you know I've got this.
You got all right. Since you got it, we're going to ensure that you really got it.
So I'm using a rectangle for my universal set.
All right.
So I like the rectangle first.
So here's my rectangle. All right.
So we know that there's set A and set B. Now, most of the segments I've seen so far, they overlap. So just draw 2 circles that overlap.
All right, so overlapping them. Remember, you're
that's
not
how-
doing what you're
that's how
telling
Venn
me.
diagram draw, you overlap the circles.
No
So
problem,
A,
man.
B. All right, so you have 1, 2, 3, 4 in set A. So you can put in those.
All right.
Whoa.
1,
Whoa, wait,
2,
wait.
3, 4. I write it in. Set B.
set
Let me
B.
run ahead, man, and help you
5,
out,
6.
man.
Oh, but look there. Look. Hold on, man. Hold on. Nothing is in the middle.
Okay.
Oh.
Okay.
So because there's nothing in common with set A and set B, all right. Just draw another
So
rectangle
there's
for me,
no
please.
what? I
There's no
want you to-
intersection.
all
There's
right.
no intersection.
Great.
So that means not all Venn diagrams will have the inner circles overlapping.
Good.
So let us try a different display.
And I hope you're following me.
I'm paying attention.
All right. We're going to see. This is
draw
your
my
second
rectangle.
chance. I have your rectangle.
Yes, I will label it U because that's my universal set.
Yes.
Then I have set A, a circle all by itself.
Set A.
Another circle on the right, do not overlap.
All right.
Good. Set B. So the elements in set A are 1, 2, 3, and 4. In set B, I have 5, 6, and 7.
All right.
Now let me just confirm that all my members of the universal set is there. Yes, it is.
It is there.
Good. So the next question, can you describe the relationship between the 2 sets? Well, they're not joined.
Yeah, so if them not joined, give me a word to say they're not joined. Come
They're
on.
separate?
Really? All
All
right.
right.
You're going to think of a word with join.
All right.
That means they're not joined.
Disjoint.
All right. Good. So they're disjoint
Disjoint.
sets. So
There
here
you
goes.
go.
Disjoint sets.
Okay, cool. So once the sets do not have an intersection, do not have anything in common. So if set A and set B do not have an intersection, the inner circles are represented separate and apart, and they're disjoint.
Yes.
Okay, cool. I get that.
Let's go a little bit further now. At a high school of 500 grade 9 students selecting their options for grade 10, there are 125 students who selected subjects in business category. 257 students selected the science category, and 52 students selected both.
Right, so we have business would have been 125.
All right, so 125, yes.
Science would have been 257.
All right, so that's 257, all right.
And both students,
Both students
I
or
mean,
both
students selected both
subjects.
subjects.
Right.
Both subjects would have been 52.
52. All right.
And the entire high school group that they're looking at is 500.
So the universal set
It's actually grade 9 students. 500
All right,
grade
so
9,
the grade
right.
9, which is
It's
the grade
fine,
9
universal
students.
set. It's fine.
Yes, so it's grade 9 students.
Right, and that would
And we
have
have
been
it to be
500 in
500
count,
because I
right.
want them to understand how we arrive definitely at our 500.
All right. So we're asked to create a Venn diagram to illustrate this information. So when you look at our questions, I'm appreciating what you just did. You took out the information that was offered within the question. All right, so let us Venn diagram this thing up.
All right.
Now, why did you draw it like this? You overlapped it.
Yes, because guess what? I was told something very important. 52 students studied both business
Science and?
science, right? So science and business, which means there's some overlapping taking place.
There's an intersection.
Yes,
so you can represent it like that.
Good. If there's an overlapping, there's an intersection.
Okay. So what can we do?
So we're going to start with the intersection first. Sometimes it seems like it's the easiest way when we're drawing our Venn diagram.
Makes
So
sense.
let's start there. So it would be
All right.
52, great.
52 in the intersection.
So what if we want to look at A now? So remember A, set A would have been
It would have been the science.
set A, science.
Yeah.
All right, science, good. So set A is science. So tell me now.
No, selected set science and set B represents. Right.
Yeah, man.
All right. So set A is a science. So since 52 students did both.
Both,
And you
great.
told me that there's 257 students who did science.
Science?
I'm going to have to take out that 52 out of it.
Why?
Because I'm going to count them twice.
All right. So when you take it out, what would we write then? So it would be what?
It would be A only? Or it would
Yes.
be
So-
257 subtract 52.
All right. So set A only
Right.
would be 257
257
students,
students
subtract our
52
subjects,
students.
which is 205.
205 students.
Right.
Great. So let's look at the set of business only. Well, already accounted for the 52 students who did both science and business. So I'm going to subtract 52 from 125.
Right.
Which gives me 73.
73.
For my B only.
But
Is that it?
that's what I'm wondering. Is that it? We were told that there were 500 grade 9 students.
And roughing it, estimating right here, 205 and 52 and 73 doesn't make 500.
No. So what we're going
If
to
you
do
run it.
then?
We have to figure out who are those students who did neither science nor
business.
So there were 500 students. We're going to subtract 205 from that, 52 from it, and 73 from it.
All right. So we can add all three of them to one,
Most
subtract
definitely.
them. So that would give us 170.
Okay.
All right. So,
So
we're still
this is what
using-
our Venn diagram would
look
look like
like.
to represent that information.
Great.
All right.
So let's use our same Venn diagram now to complete the table, and we're going to be explaining our answers. So here we are asked, so the first one is asking us the number of elements in set B. So what's the number of elements in set B?
So pay attention to the notation, the symbol that is used. It's a common N and regular bracket with the capital B inside, number of elements in set B. Now, you're talking about set B, right, Kameh? So you're talking about that B.
all of
52 plus the 73.
Great.
So that would be our...
125.
All right.
All
Then
right.
the next one.
So the next one is the number of elements within A intersect B. This one
That's
easy,
easy.
man.
That's 52
All
because they
right.
pretty much told us that.
Good. Next one,
right.
pretty simple too.
Okay.
The number of elements in the union of sets A and B, which we know this already.
We combining everything.
All right. So when you
Okay.
combine, it would be 205 plus 52 plus 73,
Giving
which
us
would give us
330.
330. But let's see if they're following at home now. So we're taking it a little notch further. Now we're asked to look at the number of elements in B only. So outside of B, remember, you know?
You mean B complement?
Yes.
B
Yes,
complement.
B complement
All
outside
right,
of
so
B.
you're talking about everything outside of B. So if you just imagine that I've shaded B, right? So I have the 205 and the 170, right?
All right. So
So-
here,
Right.
All
so we
right.
have the 205 plus the 170, which gives us
375.
375.
All right, the
Okay,
next
great.
one now. What is the number of elements in A intersect B?
A union B.
Which one?
Complement,
Oh,
yes,
a
that
rushing,
one.
a rushing the
Right.
gunman. So the number of elements in A union B complement.
So you want us to
Everything
find the union.
outside of the
Okay.
union of
All
A and
right.
B.
So A, 205, 52, that. So all of that outside of it is 170.
All right, 170. Good
Right.
job. And now we're at the number of elements within A intersect B, all complement.
All right, let me go back
So
to that
everything
now.
outside. So see the intersect here?
Intersect 52
Everything
is the complement.
outside.
So you, okay. So that would be 205
Right.
plus 73 plus 170.
You sure?
Yes.
All right.
Yes.
All right. So now the
So that's 400
48.
448.
good. But now
We have the number of elements in A complement intersect B. A complement, everything outside. This is like the thing that you did earlier.
Yes,
so
good.
it's A complement, everything outside of A intersect B, 73.
all right, good. So remember,
73.
yes, you are right. So remember for this one, A complement outside of A, which
But
would
it
have been
intersects.
right, because it would have been 73 and
plus
170.
Right.
But we're looking at the intersect of B. So we're looking at A complement intersect B, which would be
Exactly.
73.
All right.
I think they're getting it.
I hope they're getting it. Because
Now-
set notation is pretty easy. Once you understand what each of those notations stands for,
yes.
it becomes much easier. All right.
So this one is, you said something about this earlier, so let me see if you're following. So here we have set A, which is 1, 2, and 4. And we have set B, which is 1, 2, 3, 4, and 5. What is the relationship between these sets? So you tell me that I'm tricking you. I want to see now if you get this one, because if you don't get it,
What's the relationship?
Uh-huh.
Well, I can, just from examination, observation here, I see all the elements that make up A inside of B.
you're sure?
Yes, ma'am.
So list the elements for me then.
1, 2,
Right.
4, that's set A. And I can find 1, 2, 4 also in set B.
Great. So what would be, so apart from you saying, all right, all the elements in set A are also a part of set B, give me a math term then that you would use to describe this type of relationship that is taking place.
All right. It is, I know this term because I've heard it. It is a subset.
All right,
It is
good.
a subset. You hear the term? Subset. So it can be found in the other set.
Right,
All right.
good. So let's see. So we say that set A is a subset of set B. Since every member, you would have gotten it right, of set A is also in set B. This is denoted by, and this is a symbol for a subset.
Right. So it is like a C.
A sideways,
A stretched out C?
or a stretched out C. Yeah, we
Yes.
can work with that. But let's look at what the Venn diagram would look like.
Awesome.
So here we have B on, why you think is B on the outside, the one not B on the
Because-
inside?
Well, because B has more elements, and they're not all elements in B is in A.
Great.
So A is found in B.
All right, good. You get it.
Right. So
Proud of
A
you.
is a subset of B because all the members of A is found in the members of B.
Yes. All right. Good job. Yes, finally.
Time for CSEC questions. All right.
Let's
so
see
what's
what
the first one?
So set A, I'll write them for you.
You
the
like to list,
factors
man? You like
of...
this? You couldn't just list them
No,
out.
I want to list them here, man. So I'm
All
going to
right.
list it. So
Factors of 30.
So it's 1, 2, 3, 5, 6, 10, 15, 30. All right. And
Right.
then
Prime numbers less than 10.
I know this one. 2, 3, 5, 7.
There you go.
And set C is,
Why can't 9 go into that though? The prime numbers.
that is not a prime number.
Why is it not a prime number? It's 9. It's
9
less than
has
10.
more than 2 factors.
Oh, so prime numbers are numbers that have only 2 factors?
Yes.
One in itself?
Yes.
Okay. So
All
9
right.
can work.
even numbers now. That's what, less than 10? So that's 2. You got this
Yes,
one
I got
earlier.
that one, right? I know this. 6, 8.
And 10.
Oh, it says less than 10 though.
Oh,
You can't put in 10.
All
Less
right.
than.
All right.
Okay.
So here we're asked to find.
That's extra comma after 8.
Oh, yes.
Okay.
So here we're asked to find the number of elements in A intersect B intersect C is.
So
you
what
can
you're
give me
saying right
options.
here is that you can have 3 sets intersecting. They can overlap.
Yes, you can even have 4.
What does that Venn diagram look like though?
Really? We're going to explore that
All right, no
another
problem.
time, not right now.
All right.
So let's look here. So we have
A.
2.
Oh.
So 3 is in set A and B, but not in C. So
what kind
I
is
would
that?
say it is 2.
That's it?
So no,
Fine,
that's not it, because guess what? I remember something that was stated to us.
What's that?
It says it is the number of elements in A intersect
is
B
not-
intersect C.
It is
so it
not.
can't be 2.
Oh,
So it's just
it's
1.
So it's the number of
1.
elements. So it's 1.
Guess what? Tamika asked something very important. She asked us, if we can have 3 sets intersecting. Overlapping. So
Intersecting
I
is the correct term I should
ensured-
use.
Yes, that's
I appreciate the
drew
diagram.
the Venn diagram. So here is our universal set. We have set A, set B, and a set C.
And you mentioned, although we circled the 2, although we highlighted that the 2 is common to all 3 sets, it is not the 2 that I write.
No.
But it is the number of elements
Yes.
that will be found in that intersection.
Great,
And
because
if we-
remember, this important part of the
That's
question
common
says
N.
the number. So this
Right.
means the number
Of
of the
elements.
elements in A intersect B intersect
And,
C.
and you did, I really appreciate the Venn diagram on the board. You highlighted that there's only one element in the intersection of all those 3 sets.
One.
Okay, and that element is 2, but
You
it
know,
is 1 element.
I have a writ again, so you did not give me the solutions for me to try and
Oh, well.
even to guess them.
You see, and if we saw the solution at times, we may be,
Tricked
misled,
in thinking that it's
misled to think
C.
it's C because
what you thought, so I trick you.
So it's important to understand set notation, that the N means the number of elements within the described set that they gave us.
Great.
All right,
Let's
looking
look at
good.
the next one. This is
You know,
yours.
I've got this.
This is yours. So
I've got this.
in the Venn diagram,
Yes.
the
Oh.
shaded region represents.
All right, so I would have looked at P, and everything outside of P is shaded. So
Right.
of course, I'm going to bring up everything, but right away I would have.
But you still don't tell us.
It's B complement.
Why?
It's P. I'm saying B. It's
Okay.
P complement because nothing inside of P has been shaded.
All right.
Everything that is shaded is found outside of P. That means I'm looking at the complement of P.
Okay.
All right.
Good.
So there you go.
Let's look at the third
all
one now.
And we've got this. The Venn diagram X
You
represents.
sure we got this?
Represents a set of factors
right.
of 6. Y represents the set of factors of 4. The shaded region represents.
We got this, man.
Oh, you know what I was going to say though? I was going to say X
No,
intersect
no.
Y.
You said we got
But
this.
that's not the option right there.
Okay.
Oh, so I'm going to have to look at, you'd like to do this, Iman? I'm going to have to look at all the elements in X and all the elements in Y.
So tell me, what are the elements in
X is what again? Represents the factors of 6. So that would be 1, 2, 3, and 6.
All right.
Elements of Y would be factors of 4. That would be 1, 2, 4, and 4.
All right.
All right.
And what were we asked to find again?
To represent the members that are in that little shaded
But
section.
what does the shaded
Oh, the
region
intersection.
mean?
So it's
Great.
X intersect Y.
All right. So tell us now. See, I have it for you, so I'll help you.
So this is still pretty easy. It's 1 and 2.
So it's 1 because
Yes.
it's in both sets.
Yes.
And 2 because 2 is found in both sets
So
as well.
that's the intersection right there.
Right.
So that would be C. Look at that.
But guess what with this one? Which is why it's very important for us to not only know how to represent it, the notation, but we need to know how it looks like on a Venn diagram. Because here they didn't tell us.
They didn't. They just asked you the shaded region.
Right. So we need to know that, hey, this shaded region here that is being overlapped. So we realize set X is overlapping
intersecting
with, yes,
Y.
and we are using our math term, intersect.
Right.
That's what it means, X intersect
And you should
Y.
know how to determine the intersection of the sets by being able to list the members of each set and looking for what is common to both sets.
Great. Good job.
Here we go.
This one is pretty simple now. So we
if C
listed
equals
2, 3, 5, 7, V is 2, 3, 6, and A, set A is 2, 4, and 6. Guess what?
It's still intersection here. So let's see, C intersect V intersect A. So let's see. 2.
You sure? What about 6? I'm seeing 6 and I'm seeing 3.
Yeah, but it's only in 2 of them. You see, and they have to be in all 3 of them. So those are out. So it's just 2.
Just 2.
Just 2.
All right.
So that's option A right there. All right. So I guess another point to note: don't be misled by a double up.
No.
It has to be tripled if you have the 3 of them.
3, because we're given 3 sets, so we have to look at it.
V intersect A.
Great. So we have to look at.
It has to be common to all 3 of them.
Great.
All right, not just 2.
All right.
The Venn diagram. In the Venn diagram, N, the number of elements in P is 5. Right. The number of elements in Q is 9. The number of elements in P union Q is 10. That don't add up, Camille. How you get that? 9 and 5 is 14. And that's 10.
Guess what? Remember when we were looking at our Venn diagrams, and we looked at P union Q.
Right.
It was everybody, including the intersect.
Oh.
So it was every.
So right away, because this number don't add up, there's an intersection.
There is so that would have already been accounted for twice.
Got you.
So it would have been accounted in the number of elements in P. And it would have been in Q.
Okay, great. So what they're asking us, what is the number of elements in P intersect Q? So they're asking us to find that intersection.
Hold on, man. Okay. I think I want to draw it.
All right.
I want to draw it because I want them to actually see what we're talking about. So universal set, and we have
P, and we know the intersect.
Yes.
So we can overlap.
So we have P and we have Q.
Right.
All right. So we're trying to find the intersect. So say we give it a variable.
X.
All right.
Fine.
So we have X. But we were told that what?
P is 5. So 5 subtract X.
All right. That would give us only. Good job.
Okay.
And B.
Q would be 9.
Yes, Q, 9.
So it's 9 subtract X.
Right.
Okay. Because you have the X in the middle already, so you have to subtract it from. All right. Good. So P. So how are we going to find? Okay. So we know that the union is 10.
Right.
So we know that the union of P and Q is 10. So it's 10 equal. No, not right. No. Erase the universal set.
All right.
So it's down here now. We're trying to find
so
that
10.
X. 10 equal 5 subtract X all in bracket.
X.
Plus 9 subtract X. All right. Let us solve for that X.
And when we simplify.
Right.
So let me just remove the bracket. So those who are at home looking.
So 9 and 5 is 14.
14
and
minus
then that's
X.
right.
And
so now let's work it through.
Yes, because we're trying to find X. So
right.
we need to subtract 14 from both sides of our equation.
And that will give us -4, -X.
Right.
So we'll multiply throughout by -1.
Or we can divide.
Or we can divide it.
Multiply by -1. Or divide, which is...
and that will give us 4. So X is 4.
So the number of elements in P intersect Q is 4. All right, so we're going to give them one more.
Oh, yeah, sure.
That's for them to take home.
Oh, before we do that.
Yes, so just for them to take home.
So look at it and try this at home.